Good morning to everyone. Today we are going to discuss about OSI model in data communication and networks. Okay, first I introduce myself. I am Sankita, professor from IT department. Today we are going to discuss about OSI model. So first we will discuss about what is OSI. That is Open System Interconnection, which is approved by the ISO organization. This model is established in the year of 1947. What is open systems? Why we are going to open systems? That is, open system is a set of protocols which is used for different communications. That is, different systems want to communicate with each other. We need OSI model. That is, without changing its hardware and software requirements, the two systems can able to communicate with each other. So that is, we are going to OSI model. This model is implemented in each and every device. For example, our laptop, desktop and Android mobile, all the mobiles, our OSI model is implemented. This model contains 7 layers. The first layer is physical layer, data link layer, network layer, transport layer, session layer, presentation layer and application layer. So 7 layers are there. To remember this layer, some shortcut is there. That is, please do not throw some pizza away. Please do not throw some pizza away. For example, there is here P represent physical layer, do, T represent data link layer, N not, N represent network layer, do not throw, T represent transport layer, SAM, S represent session layer, P represent presentation layer, then final layer is application layer. So totally 7 layers are there in OSI model, which is used for communication. That is, two systems want to communicate with each other without changing its hardware and software. We need OSI architecture. This architecture, that is, this model is implemented in each and every device for communication purpose. First, we discussed about the physical layer. Okay. This is the diagram of how there are layers for interaction. That is, interaction between the layers in the OSI model. For example, here device A communicate with device B with the help of some connecting devices. With the help of some connecting devices, that is, some intermediate devices. Here, connecting devices nothing but switches, router or any devices. With the help with, for example, A want to communicate with B, which transfer the data through some intermediate devices. That intermediate devices may be switches, routers, gateways, hubs or anything. Okay. For each device contains 7 layers for communication, and all intermediate devices are using 3 layers only. 3 layers only. That is physical, data link layer and network layer. Okay. So that these are 3 layers only used for the communications. That is, connecting devices are using only 3 layers. Now we are going to discuss about what is the function of, what is the purpose of each layer. Physical layer. Physical layer is used for transmitting the data in the form of bits. Transmitting the data in the form of bits, and also it is used for defining the electrical and mechanical specifications. Its data link layer. This layer is responsible for converting the bits into the frames, and also it is responsible for hop-to-hop delivery. That is, hop-to-hop delivery or node-to-node delivery. What is the meaning of hop-to-hop? Means the device can transmit the data from one device to the another device. That is, another intermediate device. That is called hop-to-hop delivery. The next layer is network layer. This third layer is network layer. This layer is responsible for source to destination delivery. Source to destination delivery, and also which is used for converting the frame into the packets. Frame into the packets. So source to destination delivery means, that is, device A want to communicate with device B, means that A and B here called source and destination. Okay. So network layer is responsible for source and destination delivery. And transport layer, this layer is responsible for end-to-end message delivery. End-to-end message delivery and error recovery. So what is the meaning of end-to-end delivery? Means that is process-to-process delivery. For example, in our device, in our system, number of processes are running in our systems. For example, we can access Gmail, Rediff Mail, Google.com or Facebook or anything. So number of processes are running in our system. To identify the process, port number is needed. So for For that purpose, we are using the transport layer. This transport layer is the purpose of process-to-process delivery or end-to-end message delivery. The next layer is session. So, for example, if you want to maintain the session or if you want to synchronize the session, we need session management techniques. So, that techniques contains the session layer. The session layer is used for establishing the session, managing the session and terminating the session. The next layer is presentation layer. So, for encryption, for privacy, for security purpose, presentation layer is included in the OSI model. So, what is the purpose of presentation layer means? For example, if you want to encrypt the data or if you want to compress the data, translate the data, decrypt the data, presentation layer is needed. So, this layer is used for encryption, decryption and also translation and compression. So, this layer is included here for the security and privacy purpose. Okay. The last layer is application layer to allow access to network resources. For example, user want to communicate, user want to access the data, we need some set of protocols. For example, HTTP, Hypertext Transfer Protocol, FTP, File Transfer Protocol, Telnet, some protocols are implemented in this application layer for managing the files, for retrieving the files, for accessing the files. So, user want to access, retrieve, manage the files, the application layer is needed. So these are all the purpose of 7 layers. The first we will briefly discuss about physical layer. This layer is responsible for movement of individual bits from one hop to the next hop. Physical layer is responsible for movement of bits from one hop to the next hop and also it is responsible for. So, physical means it will always represent the medium. Okay. So, physical layer is responsible for representation of bits. That is, our data is transmitted in the form of bits. That is, maybe zeros and ones. That is encoded. When we are transmitting data in the medium, that is encoded. That is, it will be encoded as optical signal or electrical signal. That is called digital signals. Our data in is transmitted in the medium as digital signal and also which is used to specify this physical layer is used to specify the line configuration, topology configuration and also type of transmission mode, everything. So, we know that how the devices are arranged in the network is called topology. We know that in our college also some topologies are implemented, mesh topology, bus topology, star topology, bus topology. So, these topologies these topology configurations also supported by the physical layer and also which is used to define the electrical and mechanical specification. That is what is there. So, if you want to transmit the data, we need some medium that may be wired medium or wireless medium. So, if you go for wired medium, some cables are needed. What all the cables means? Fiber optic cable, coaxial cable, optical cable. Suppose if we go for wireless medium, we need some we do not need any cables. That is air is the example for wireless medium. So, what I want to tell, the physical layer is responsible for electrical and mechanical specification to define the transmission medium, to define the types of topology, to define the line configuration, to define the data transmission mode, simplex, half duplex, full duplex. So, those things are all supported by our physical layer. The next layer is data link layer. Which is this layer which is responsible for moving frames from one hop to the next hop. Which is responsible for hop-to-hop delivery. So, this layer is supporting framing and also physical addressing. So, what is the meaning of physical address? Physical address means that is one device address. That is MAC address is nothing but a physical address. Suppose if device want to transfer the data from one device to another device, this data link layer adds the header. Into the package. So, that header contains the physical address. That physical address is a device address. That is which device want to communicate, want to transfer the data from one to another. So, which contains the physical address of transferring device and receiving device. The next layer is network layer. The next layer is network layer. This network layer is responsible for source to destination delivery, which is used for delivering packets from the source host to the destination host. So this network layer is responsible for source to destination delivery, and also which converts the frame into the packets, and also it supports the routing. So what is the meaning of routing? Means if we want to transfer the data from one device to another device, so in between some devices are connected, some connecting devices are present, that may be routers, switches, gateways or anything. So we want to route our packet to the final exact destination. So for that purpose, routing is needed. That routing is supported by our network layer. The next layer is transport layer. This transport layer is responsible for process to process delivery. So with the help of service point addressing or port number, we can able to identify the process running in our systems. Already I told you that is number of process may run in our systems. It may be Gmail, it may be Google or Yahoo Mail or Twitter, Facebook. So if we want to identify or process, port number is needed. So based on the port number, our message will reach the correct process. So this layer is responsible for process to process delivery. That is delivery of a message from one process to another process. And also transport layer is responsible for segmentation and reassembly. That is your messages, for example, your message is divided into number of segments. Finally, the segments are arranged into the messages based on the sequence number. So that this transport layer is responsible for segmentation and reassembly. The next layer is session layer. This session layer is responsible for establishing the session, maintaining the session, synchronizing the session from one end to another end. To maintain, for example, to establish, to maintain, synchronize our session, this session layer is needed. And also dialogue control and synchronization. So for our dialogues also maintained in this session layer. The next layer is presentation layer. This layer is responsible for translate the messages, compress the message, encrypt the message, and also it is used for compression, translation, encryption, decryption. The main aim of presentation layer is security and privacy purpose. We are using this presentation layer. The next layer is application layer. This layer is responsible for providing services to the users, end users. If we are the end users. If we want to access the data, if we want to access the files or retrieve the files or store or manage the files, we need some protocols. That protocols are implemented in the application layer. So this layer is responsible for providing services to us, that is end users. So these are all the 7 layers of OSI model. So finally I conclude. So how the message is transmitted from one end to another end, that is one device to another device. So next step. Okay, look at this diagram. First, device A want to transmit the information, want to send the data to device B. Okay, first he will type the messages. In his mobile. Okay, that is in application layer. Next, your messages will be encrypted by the presentation layer. That is the 6th layer. Then session is maintained in both the ends. Both A and B. The next layer is transport layer. Look at here. Already we discussed. Transport layer is responsible for process to process delivery, and also it is responsible for segmentation and reassembly. Here your message is divided into number of segments. In the transport layer. Then come to the network layer. Now segments are converted into the number of packets. Network layer is responsible for source to destination delivery. Here message is converted into number of packets in network layer. Again come to data link layer. Here your packet is converted into the phrase. Your packet is converted into the phrase, and also data link layer is responsible for hop to hop delivery. Hop to hop delivery. Finally come to the physical layer. Here frames are converted into the bits. Frames are converted into the bits. And finally your bit is transmitted in the medium through some intermediate devices. Finally it reaches the device B. So now physical layer of device B receives the bits, which converts the bits into frames. Data link layer is responsible for making bits into frames. So data link layer makes the frames. Network layer makes the frame into the packet. Again transport layer makes the packet into the segments. Finally your message is decrypted. Finally it reaches the application layer. So segments converted into the message and reach the device B. So this is happened in the OSI layer. So please remember that physical layer is responsible for bit representation. Data link layer is responsible for hop to hop delivery. Hop to hop means one device to another device. Another intermediate device. Network layer is responsible for source to destination delivery. This is the exact address of device A and device B. Next, transport layer is responsible for process to process delivery. So session for maintaining the session between two ends. Application layer, that is presentation layer, is responsible for encryption, decryption, and also security purpose. Apparently application layer is used for accessing the data. Thank you. That's all. Thank you.